Okay, now we have the definition of the average velocity and average speed. You can see that the average velocity and speed give you the rough idea of how fast a particle moves, but they are averaged over a finite time t. So it means that it not give you the detailed information of the velocity at every instant. So if we need that information, we have to define the instantaneous velocity and speed. Using the concept of calculus, we define the instantaneous velocity as follows. Instantaneous velocity, we define it as Vx is equal to the limit of delta t approach 0 of delta x over delta t, or we can use the notation of the calculus to write this as dx by dt. So it means that if we know the mathematical or the functional form of x as a function of t, we can calculate the instantaneous velocity by calculate the derivative of x respect to t. We can also define the instantaneous speed as the magnitude of the instantaneous velocity. The instantaneous speed, v is equal to the magnitude of Vx, or is equal to the magnitude of dx by dt. From now on, when we say the velocity, it means that it is the instantaneous velocity. We will drop the word instantaneous, except we really need it. So when we say that velocity, it means instantaneous velocity. If we say speed, it means instantaneous speed. If we want to specify like the average velocity, we have to specify it is the average velocity. But if we say velocity, it means that it is the instantaneous velocity, and the same also for the speed. Now, let's see the graphical representation of the instantaneous velocity. And of course, once we know the instantaneous velocity, we know the instantaneous speed also. Let's see this graph. On the left, it represents the position, the graphical representation of the position as a function of time. You can see that you can calculate the average velocity between any time interval. For example, you can calculate the average velocity between A and E, or A and F, and also between A and B, using the formula we already discussed. Now, If we want to calculate, or if we want to represent the instantaneous velocity at point A, we can follow the concept or the definition of the instantaneous velocity, that is the instantaneous velocity Vx is equal to the limit of delta t approach 0 of Vxf minus Vxi over delta t. Okay, so if we want to calculate the instantaneous velocity at point A, at this point A, and if we zoom this area to the second graph, this is the point A. When we see the process of limit here, it means that we can do that by move the point B to approach A, right? Move the point B to approach A, and you can see that from this definition, this is the average velocity between the time interval between A and B. And when we take the limit, it means that the time interval becomes smaller and smaller, and it means that we move B to approach A. The slope of this line joining A and B will become closer and closer to the tangent line. Okay, to the tangent line at point A. Okay, so graphically we can say that the velocity the value of the velocity is the slope of the tangent line at point we want to find the instantaneous velocity. In general, slope of graph of physical data represent the ratio of the change in quantity represented on the vertical axis to the change in the quantity represented on the horizontal axis. In our case, it is the rate of change of the displacement to the change of time. Remember that a slope has unit. This is important. Unless both axes have the same unit. Okay, the unit of slope here for the instantaneous velocity are meter per second, which is of course the unit of the velocity. We next discuss a very simple model. Once we have the definition of the instantaneous velocity, we can go further to the model of the particle under constant velocity. Okay. In this model, we have that Vx, which is equal to the dx by dt, is a constant. It means that Vx has the same value all the time. So from this in this model we will have that Vx, which equal to the dx by dt, must equal to the delta x over delta t for every time interval. For every time interval. This is because when the velocity is a constant, it means that if you calculate the average velocity, it must equal to the velocity at any instant, right? Because at any instant the velocity is a constant, so the average is equal to the velocity at any instant. So from this relation we must have that delta x is equal to Vx delta t, or we have that xf minus xi is equal to the Vx Tf minus Ti. Okay. Usually we can choose Ti to be 0, and we will write Tf as just T. We will have that xf is equal to the xi plus Vxt. So this is the equation of motion for a particle moving under constant velocity. We can see that if we draw the graph of x as a function of t, we will have a straight line like in this figure. And from this figure you can also see that since the velocity is a constant, the slope of xt is a constant too, so that's why we have the straight line. And from this graph you can see that if you want to calculate the average velocity at any over any time interval, like in this interval or in this interval, you will get the same value as we discussed before. So that this is the character of the motion of the particle under the constant velocity.